This is Mr. Curtis with your video lesson for the week. This week's topic is over angles and triangles. We will discover the relationship between the sides of a triangle, the sum of the angles of a triangle, the number of different triangles that can be formed, angle relationships, and how to find the measure of a missing angle. So these are our focuses for this video. To start off with, we're going to talk about the sides of a triangle and how they are described. So to begin with, tri means three. So when we're talking about a triangle, we're talking about an enclosed figure that has three angles. So here we have 6 different types of triangles based off of their sides and their angles and how they're described. First off, we have a scalene triangle. A scalene triangle has no equal sides or angles. The length of the sides and the measurement of the angles are all different. They're not the same. Then we have an isosceles triangle, which means that we have 2 equal sides and 2 equal angles. Then we have an equilateral triangle, which means all the sides and all the angles are equal to each other. Next, we have an acute angle, which means that the 3 angles are less than 90 degrees. Notice it doesn't talk about the length of the sides here. A right triangle is a triangle that has one 90-degree angle and 2 angles that are less than that 90 degrees. Once again, notice that there is nothing here that talks about the length of the sides. And then an obtuse triangle has one angle that is greater than 90 and then 2 angles that are less than 90. So if I'm talking about an acute, a right, or an obtuse triangle, the length of the sides is not relevant to them. But if I'm talking about a scalene, an isosceles, or an equilateral, it's referring to both the angle and the length of the sides. So what we're going to do now is we're going to look at the rule of the sides of a triangle, which means that in a triangle, the sum of any 2 sides must be greater than the third side. So that means is I can take the sides of any triangle and add them up 2 at a time, and it should be greater than the remaining side. So here I have an example. We're going to go through 4 different ones to show you what I mean. So triangle A has length of 2, 3, and 4. So what we're going to do is we're going to take those 3 numbers and we're going to add them together in different ways to where I'm adding only 2 and comparing it to the third number. So here I have 2 plus 3, so that's side 1 plus side 2, and it's equal to 5. Well, 5 is greater than 4, that remaining side. So that works out. Then I can take 3 and 4, side 2 and 3, add them together and get 7. 7 is greater than the other side of 2. That works out as well. And then I'm going to take my last 2 remaining pairs of side 1 and side 3, add them together, and I get 6. 6 is greater than 3. So because all 3 of these, when I add them up and compare them to the third side, it is greater than the remaining sides. So that means that these 3 sides can equal a triangle. So now if I look at these numbers, 2, 3, and 6. So if I go through and start adding them together, 2 plus 3 is 5. 5 is less than 6. 3 plus 6 is 9. 9 is greater than 2. 2 plus 6 is 8. 8 is greater than 3. But because of my first one there, 5 is less than 6. That tells me that this is not going to be able to make a triangle. Imagine that I were taking toothpicks and that the number of sides here tells you how many toothpicks I have on each side. So side 1 has 2, side 2 has 3, and then side 3 has 4. I could arrange a triangle with those number of toothpicks, and it would make a triangle. But if I tried doing this one here, this is going to either have a gap between 2 sides, or it's going to have a side that overlaps and hangs off. So side C here, we got, or triangle C, we have 5, 6, and 10. We can see that when we add them all up, it's always greater than the remaining side. So yes, this does form a triangle. And then triangle D, 5, 6, and 11. Well, I can see here when I do 5 plus 6, I get 11, and 11 is equal to 11. It has to be greater than, not equal to, not less than, but greater than. So this one would not be a triangle. All right. Now let's talk about the angles of a triangle. So the sum of three angles in a triangle will always be exactly 180 degrees. Exactly 180 degrees. So here as an example, I have an angle of 109, an angle of 48, and an angle of 23. When we add those together, we do get 180. So that means that this right here is in fact a true triangle. So we're going to talk about an abstract concept that I'm going to do my best to explain. The angles and number of triangles. Okay, this is important. You do have a question this week on your mid-module check that talks about the number of angles or the number of triangles that can be made based off of the angle relationship. So please try your best to pay attention to this section here. When the sum of three given angles is 180 degrees, those angles can be used to form an infinite number of triangles with different lengths. It doesn't matter what the degree of the three angles are, as long as their sum can be 180 degrees. So if we're looking at this, here's my example. I have a triangle that has the measurements of 80, 60, and 40. Well, because I have three angles, when added together give me 180, I can take this triangle and I can make different size triangles in order to illustrate that. So the first thing I can do is I can make it larger. So you notice that the lengths of the sides have gotten bigger. So this one was 1, it went to 2. This was 2.5, it went to 5. This was 3, it went to 6. So the length of the sides all doubled, but the measurement of the angles stayed the same. I can also shrink it. I can make it smaller. So I could take the lengths of the sides and divide them by 2 and make them smaller. So 1 becomes half, 2.5 becomes 1.25, and 3 becomes 1.5. The lengths have been made smaller, but the measurement of the angles are still the same, 60, 80, and 40. So as long as the three angles can be added up to equal 180 degrees, I can make an infinite number of different sized triangles. When the length of two sides and the angle between them is given, only one triangle can be made. That's because of the sides, number of sides that we just talked about earlier. They have to equal up, or the third side has to be less than the two sides that add together. And the angle that is given has to be less than 180 degrees. So just remember, if I give you a degree measurement and it's less than 180 degrees, and I give you two lengths of a side, then that tells me I only have one triangle that I can make there. When the sum of an angles is not 180 degrees, no triangle can be formed. And the sum of three angles must be exactly 180 degrees. So here we have some different angle measurements: 40, 60, 80, 45, 45, 90, 10, 20, 150, 45, 45, 85, 10, 20, 110, 30, 100, and 100. So we're going to go through and we're going to add these up and see if they equal 180, because if they do, we have a triangle. If they don't, we do not have a triangle. So let's do the first one. 40 plus 60 plus 80, that is 180. We got a triangle. 45, 45, 90. 45 plus 45 is 90. 90 plus 90 is 180. Yes, we have a triangle. 10, 20, 150. So 10 plus 20 is 30. 30 plus 150 is 180. Boom, we got a triangle. 45, 45, and 85. Well, 45 and 45 make 90. 90 plus 85 is going to be 175. No, not a triangle. 10, 20, and 110, that's only going to give us 140. Not a triangle. 30, 100, and 100, right there I have 200, so it tells me it's going to be over 180. So I know that this is not a triangle as well. So the big thing to remember about triangles is that the angles of the triangle have to be 180 degrees, and any two sides of a triangle, the sum of them, has to be greater than the third side. Now we're going to talk about angles. We have 5 different angles that we're going to talk about, and I'm going to have some pictures to go along with them as I read through the definitions. So the first thing is a straight angle. It's a line that measures exactly 180 degrees. It's like a straight line. So right there, boom, straight line, 180 degrees. A vertical angle. 2 angles that are directly across from each other when 2 lines intersect. So right there, I have 2 lines that intersect. So 2 straight lines intersect, and they create 2 pairs of vertical angles. So if right here, A and B, they're vertical. D and C, they're vertical. They're directly across from each other. Supplementary. 2 angles whose sum is 180 degrees. They create a straight angle. So here we have 130 and 50. Well, 130 plus 50 is 180 degrees, and they form a straight angle. So these 2 are supplementary. Complementary. 2 angles with a sum of 90 degrees. They create a right angle. So here we have 50 and 40. They create 90 degrees, which means that this is complementary. These 2 angles are complementary to each other. And then adjacent angles. Adjacent angles are angles that share a side. So for instance, 130 and 50, they share this side right here. 40 and 50, they share this side right here. So 50 is adjacent to 130, and this 50 is adjacent to this 40. All right, now we're going to dive into examples. Now, if anything you copied down from your notes from this video, it should be at least the examples. I would love it if you copied down the other parts of the notes as well, but the examples are the biggest thing that are going to help you with your assignment this week. So here's first 2 examples, 1 and 2. Can the following lengths of be the sides of a triangle? 8 inches, 10 inches, and 20 inches. So this goes back. When we add the 2 sides together, is it going to be bigger than the third? Because if it is for all 3 sides, then we have a triangle. So let's go through and look at this. Let's start with 8 and 10. 8 plus 10 is 18. 18 is less than 20. 10 plus 20 is equal to 30. That should be 30. 30 is greater than 8. And then 8 plus 10 is 28. 28 is greater than 10. So do we have a triangle here? The answer would be no, because 18 is less than 20. The sum of any 2 sides must always be greater than the third. So example 1, no, we do not have a triangle. Let's look at example number 2. Can the following lengths be the sides of a triangle? 19 feet, 23 feet, and 42 feet. So let's go through and add them together. 19 plus 23 equals 42. 42 equals 42. 23 plus 42 is 65. 65 is less than 19. 19 plus 42 is equal to 61. 61 is greater than 23. So does this make a triangle? The answer is no, because of the fact that 42 is equal to 42. The sum of any 2 sides must always be greater than the third. That is the takeaway from these 2 examples, is that the sum of any 2 sides of a triangle is greater than that third remaining side. All right, let's look at example number 3 and 4. How many triangles can be formed if one angle is 100 degrees and the other is an acute angle? So let's think about that for a moment. Triangle angle sum is 180 degrees. All 3 angles added together give us 180. An acute angle is an angle that is smaller than 90. So let's take a look at that. So let's think about that. Let's say the angle is 70 or 10. So 100 is one angle we have, and then one of the other 2 angles is either going to be 70 or it can be 10. Either way, when I add them together, I get 180. There's one triangle. I have an angle of 100, and let's say the other 2 angles are both 40. They're acute. That's 180. That's 2 triangles. Let's see if I can go for more. 100 plus, let's say 25. That means the third angle is 55. That gives me 180. So when I'm given one angle, and then I'm told the other angle is an acute angle, I can form more than two triangles. How many triangles can be made if one angle is 100 degrees and another angle is obtuse? So once again, we're thinking about the angle sum theory here. We have 180 degrees is what we should be equaling out to. Obtuse means we have angles larger than 90. So let's start with one larger than 90. 100 and 105. Right there, that's 205. That's bigger than 180, so there's no point in even me bothering to find a third angle. Okay, let's try something smaller than that, closer to 90. 100 plus 91, still 191. It doesn't work, it's bigger than 180. So when I have an obtuse angle and an angle measurement, more than likely, I'm going to have no triangles that can be formed. Example number 5, find the value of x. So here we have three angles inside of a triangle and then a vertical angle to y. So we know that one thing, 72 plus 40 plus y, these three angles here, is 180. And then y plus 112, which is the sum of these two, is 180, which means the value of y is 68. 68 is going to be the value of x because x and y are vertical angles. Vertical angles are equal to each other. So x equals 68. And then my last example here, in the figure, angle y and angle x are vertical angles, which means they are equal to each other. Angle x forms a straight line with the 65 degree angle and the 55 degree angle. Write and solve an equation to determine the value of angle y. Well, first we're going to find out the value of angle x because they tell us that these three angles here form a straight line, which means if I add those three together, I'm going to have 180. So I can solve this down to find out what x is. 65 plus 55 is 120. 120 plus x is 180, so x is 60. That's the first part they want me to do here. I wrote my equation down, this right here. The second thing I want to do is find out what the value of y is. They tell us that right here. They're vertical angles. So x is equal to y, so y is equal to 60 degrees. All right, guys, that's my video. If you have any questions, please join me on Wednesday for a small group lesson where I can get a little bit more one-on-one in depth with you to help you with this. If you don't need